Good day to you, my dear friends. It's time to solve some LeetCode problems. Yay! It's very windy today, so sometimes it gets very loud. I'm sorry for that, but we have to solve LeetCode problems no matter what. But first things first. And let's start with the problem that we solved almost a week ago. And let's discuss the best approaches to this problem. Or maybe our approach was the best. We'll see about that. Do remember this problem, or minimum score by changing two elements. It's a hard problem to solve, but it is even harder problem to describe. Oh. The solution is quite simple. So we have an array of numbers. We want to find the smallest difference between any number and any subsequent number. Not subsequent, how do we call it? Later number with bigger index. The smallest difference. And notice that this must be a smallest difference with absolute value. What does it mean for us? Let's say here the smallest difference is between 7 and 8, or 5 and 4, 4 and 5. Let's say 4 and 5, okay? So it's the difference between 4 and 5, but it's an absolute value, so it is the same thing as absolute value of 5 minus 4, right? And that means that the order doesn't matter, and in our case smallest difference is just smallest difference between any two numbers. Also, we have a largest or biggest, I don't know, biggest difference. The same thing, it's the biggest difference possible in this array between two numbers. So in our case it's a difference between 1 and 8. And in the end we want to combine these two differences. So this is our goal, to combine these two differences. Now we can make two changes to the array. We can, in one change, we can replace any number with some other number, any number that we want. So we can make two replacements. And the question is, what is the minimum sum? This must be minimum that we can get with just two replacements. You see, this is a very hard description. And I spent like 2 days trying to solve this problem until I realized two things. Let's draw. So we have numbers. First of all, we want to sort them, that's for sure. Let's take this 1, 4, 7, 1, 4, 7, 8, and 5. Let's sort them. 1, 4, 5, 7, 8. Now, it is obvious that we can always make small difference equal to 0, smallest difference. How come? Because we can always change this number to any other number, say to 8, you know, and then smallest difference between two numbers becomes 0. That means that our question turns into what is the smallest, biggest difference that we can get. And of course, the biggest difference is the difference between maximum element and minimum element, like between the last and the first elements. Now, there can be different situations. In some situations, it may be the best approach to replace first two numbers. Let's say let's replace them all with 8. 8 and 8, for example. So now the difference, minimum difference is 0, maximum difference is difference between the last element and the element with index 2. But there can be different scenarios. For example, if we have something like 1, 2, 3, and 8, and 9. We don't want to change this 2 to 9, for example, because the biggest difference is 6 in this case. What we want to do is we want to replace 8 and 9 with 1s, for example. Then the biggest difference is 2. But of course there can be another situation if we have like 1, 20, 21, I don't know, 22, and let's say 80. We can't replace two of the first elements because this is a huge difference. And we can't replace the last two elements because this is also a pretty big difference. But we can replace the last and the first and the last, make them equal to say 22, right? Then the difference is the difference between 22 and 20 and just 2. So these are two changes. Well, not two changes. These are the only 3 options that we have with 2 replacements. We can either take the first 2 elements, the last 2 elements, or the first element and the last element. But how do we know what to choose? And maybe there is some kind of a tricky algorithm to do that, but I just counted all 3 variants and took the minimum value. So in our first case, when we remove 2 of the first, when we remove the first 2 elements, the difference become this difference, biggest difference, become the difference between last index nums -1 and second index. Here the difference is, this is -3, this is 0, right? Index -3 and 0. And this case, the last one, this is -2, this is 1. And I put these three variants into an array and I take the minimum value, you know. And solution section for Ruby is very small, and it pretty much, this check doesn't make any sense, by the way, because we have a condition here that 3 is, at the very least, our array is going to have 3 elements, and this check is gonna work for 3 elements also. So we do not need any guard clause or anything, it's all good. But apart from that, well, this is similar to mine, but with useless return. And this is funnier. Look at this thing. Well, let's notice a pattern here. We start at -3, then -2, then -1. We start at 0, then 1, then 2. So we increment by 1. That's why they use this funny thing. Let's do we need map? I don't remember. Probably we do not even need map for this. I don't remember. So let's say it's an element. No, it's an I. It's gonna be 0, so we do 0 -3 to get -3 minus nums I. And yeah, we want to map, of course. And now we want to choose the smallest. Let's try this. Oh, wait, it's not nums, it's sorted. Of course it's sorted. Beautiful. Well, this is not too beautiful, but it's almost random. Let's not pay any attention to this. This was notorious problem 2567. Oh, I think it was the first time that we tried to use lit rooms and we we got two easy problems and two medium problems, and we were able to solve easy problems. But the first medium problem was a problem about a rectangle. Do you remember that? I think I have like 6 videos with that problem. And the second was this monstrosity. Oof, it was a nice set of problems. But we prevailed, you know. We won. What else? Also, some time ago, Jesus H. Christ, we solved this problem. Partition array according to given pivot. Let me take my first solution. What? Nice. So we have an array of numbers and we have this pivot. I don't know how to pronounce it even. Pivot? Let's check.
Pivot.
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 Pivot. So, pivot. We have this pivot. Yeah. And we want to sort the array of our numbers. First of all, we want to list elements that are less than pivot, then elements that are equal to pivot, and finally those that are bigger. And we want to, well, within this constraint, we want to save the order of the elements, of course. And I did it in this barbaric fashion, like I created 3 arrays, and if number is less than pivot, then I added this number to first array, if it's equal then to second, and if it is bigger then to the third, and then I combined everything. No, not too elegant. But let's go to the solutions, and you're gonna notice that we do not have a Ruby. No solutions for Ruby, unfortunately. So we have to create something by ourselves. And of course, like the obvious solution would be just to iterate 3 times, for example. Yes, it can be done. Like, let's do this for fun. Let's make some array results. And notice how I try to return nums array, because I do not understand this return nums after the rearrangement. Does that mean that we want to return the array called nums also? Or it can be called anything? Because sometimes it matters in this problem, sometimes it doesn't matter. Otherwise, of course, we could just return this. But let's make a new array results. This is the end. This is our second pass. Nums each do. But of course it's even worse than my approach. It's even more barbaric to my taste. Or of course, if you want to return nums, we can do this. But after that, I invented a one-liner. Nums sort by our number, spaceship operator, pivot, and that's it. I think. Cool. I should probably publish this solution. It's nice. How does it work? So, if our number is less than pivot, then this thing is going to return -1, I believe. If it is equal, then it's going to return 0, and if our number is bigger, it's going to return 1. And it's going to sort our numbers according to that. So of course we're gonna have like all -1 numbers, then all zeros, then all ones. But for us it's not -1s or 1s or zeros, it's our numbers, you know, and they're gonna be represented in the same order. The only, of course, I did a contest, no condom Chris, and as always I solved 2 problems out of 2, the first one and the second one, and of course I was able to discover the trick in the second problem by myself, that we have to, I don't know, maybe did you try it? I do not want to spoil it for you, but there was a trick in the second question. And another contest, the one before that, also it was 2 of 4. It's like my golden standard these days. I always can solve 2 problems. I never can solve the third one, but, you know, a nice thing that I make less and less bugs. So even by solving just 2 problems, I climb higher and higher in ranks, so it's all good. No. Now I want to discuss easy problems from the first page, because, you know, I want to finish at least the first page of problems. What was the problem? 2798. Where is it? Here is it. And I thought I somehow missed it. I mean, it was solved, this problem was solved on the 30th of July, like a week ago. But I'm sure that I didn't stream it, and I was puzzled by this. How is this possible? The answer is very simple. This is a problem. This is a new problem that came from the contest. It was an easy problem from contest. So when we solved these problems like 2 weeks ago, it wasn't even presented here. What is the problem? Number of employees who met the target. So we have hours. As usual, in this problem we have Working people, lucky bastards, they have a job. I'm jealous every time I'm encountered such a problem. So, these lucky bastards, they worked some hours. The first lucky bastard, well, he didn't work at all. Yeah, the second one worked for an hour, I think. So for each and every one of them, this array represents how many hours did they work. And the target is 2 hours. So we want to count how many people, are good workers and how many should be laid off, like me. And it's a very simple problem. You just need to count. Everything that is bigger or equal to our target, and that's it. That's why this problem is so high. Oh no, of course I butchered it. That's how you fail contests. Great. And let's look into this section of solutions, Ruby problems. We have, two solutions there, and they are similar to each other and to my solution. Yeah. Now, also I want to discuss another problem from the first page. This time it's going to be JavaScript problem. And it's an interval cancellation. We already solved it, but it's time to discuss the best approaches. And this problem is very similar to timeout cancellation that we solved with no condom Chris in chat, if you remember. And this problem is very similar, but instead of a timeout, we have an interval. And another small deviation is that we immediately want to call this function and then set an interval and call it after some time. And there is an editorial, believe it or not. And what do they propose? Well, of course they always do this. I just return function, but they ask us to return cancel fn function. So we have to name it. It's not very important, of course, but why not? It was a long process, got me scared. Another way to do this is with a recursion, believe it or not, a JavaScript recursion. Let's create this ugly monster. So we want to have this new function. Let's call it create interval. Whoa, thank you very much. Thank you for the raid. Not my brightest moment, we are solving JavaScript problems here. So, hello everybody. Let's create this function. Let's call it create interval. And in this function we want to create interval, believe it or not. So, let's do set interval. Not interval. And not create interval. I'm sorry, you got me distracted. Let's call it create timeout, and we're gonna set timeout, of course. What is going on here? It's mesmerizing. What do you want to do in our timeout? Well, first of all, let's create a boolean here. It's cancelled and it's false. It is false. And here we want to make a check. If not, it's cancelled. Come on. Round brackets. What do we want to do? Well, first of all, we want to call this function, of course. With arguments. But also, we want to call this function again. And what are we going to do here? Well, here we want to set is cancelled to true. Now, when it is called, it became cancelled, and we do not continue our recursion anymore. In theory. And of course, we want to call this once. Let's check. Nice. I thought it was going to break. That's one possible solution. Another solution they propose in the editorial is that we create, let's call it timeout, and here we do not do any checks. But we're going to do this. And of course, in the end, we want to clean timeout. Should work, I think. Nope. Why? Why? Maybe it's not clean, maybe it's called clear. It's clear timeout. Of course. Please work. A charming world of JavaScript. And they say this is like the best solution because we want to clear timeouts have no idea why, but we do. Well, here we want to clear timeout just to stop doing this, of course. So it's kind of obvious. Now, what else? What else? Another problem from the first page. I want to finish with this page. What was it? Running sum of 1D array. Yeah, this is the one. Here we have an array nums, and we want to return a running sum of nums. So for this element 2, we want to take the sum of all the previous elements and add 2, and it's going to be 3. Then this element 3, we want to sum everything before 3 and add 3 is gonna be 6. And for 4, of course, we're gonna combine everything before it and add the element itself. It's gonna be 10. And there are a million ways. Initially, I did it with a while loop, I believe. Let's try while nums I. No. We want to start with 1, of course. Because for the first element we do not have any previous elements. So let's start with 1 and we're gonna increment in the end. And nums I is gonna be equal to nums I minus 1 plus nums I, and we're gonna return nums. See, we do this on the go. Great. That was my first solution, but actually you can do this with a map method, for example. Let's do not nums map and what do we want here? Here we want sum plus equals underscore 1. So we return sum plus this element and we increment sum by this element at the same time. Oh yeah. Dun, 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 dun. Dun, dun, dun. Dun, dun, dun. Dun, dun, dun. Or if you want to cheat a little, we can put this line here, and then this is a one-liner. Yeah, I know, I am a dirty bastard. Also, we can do this with an exclamation mark, so that we do not return a new array, but modify the same array on the go. Is it gonna work? Let's hope. For the best, it's green. Good, but these were all problems from the past that we already solved one way or another, and we just discussed the best approaches. Now it's time to solve the ugly problem. As you probably remember, I visited this contests page, the last page, and I took this warm-up contest. and it was brutal. They give just 1 point for each problem, but they are hard, except for this one. This one is easy. Lexicographical numbers I was able to solve the next day, if you remember. Now it's time to solve this abomination, longest absolute file path. And let's do this. Wait a second, where is it? I want to solve it in a more familiar interface, because it's a lot nicer. Come on. Of course, there's no guarantee that I'm gonna be able to solve this. Let's try. I mean, this problem, it's even hard to look at. There are so many like visual garbage, so many distractions, you don't even understand where to look, what to do. Now, judging from this picture, well, you see they give us these lines. So every new line is divided by n, and every new level of depth is marked by t letter. So if file is 2 levels deep, it's gonna have 2 t's, and we must return the longest path to a file. Like here there are 2 files, but a path to this one is the longest, of course. But that is because they use this convention, like they call a subdir a subdir, then they call sub-subdir, and so on. So of course, if we encounter the file later, well, not later, but deeper, then for sure it's gonna have the longest path. But I'm not sure if this is always the case. Who knows? Like here we do not have a number and file name. In other words, I do not know if this pattern holds. Maybe it exists only in these 3 examples. We can have input A, no files. Now, of course, we can do something like split by and probably we want to free this symbol. I don't know. Let's see what we're gonna get. No. Maybe we do not want to free anything. Wait. I forgot. Maybe it's another type of slash. How do we free something in Ruby? I don't remember. Maybe we need like I just forgot. I forgot my language. I'm sorry. Let's Google it. Will be split by new line. What? Okay. So if we encounter a file, okay, let's call it R, like pirates do. Now let's iterate. It's not a hard problem, it's an ugly problem. I do not like the way it looks. Okay, it's element of the path. Let's have a string. See this file, it has two T's, so it's 2 levels deep, we know this for sure. But it can be here 2 levels deep, or it can be here 2 levels deep. You know, there are many different variations. Okay. We want to count this, let's say. And let's say we want to have a hash. Why not? Let's call it depth. And hash depth is going to be an empty array or itself. And now we want to add our element to hash depth. Only if depth is more than 0, because we know that it all starts with dir. Or do we know? Nah, let's do everything. We may just say return 0 if depth is 0 and element doesn't equal to dir. A little guard clause. At least the third one should be solved. Yeah. And let's return hash values just to see what do we have in our hash. If our element, do we have include method for strings? I don't remember. File else this. We want to do this no matter what. Depth -1 times do. S plus equals hash I caramba. So we have an S. Let's check it immediately. Oh yeah, we want to take the last one, the last element of that array. Dir. Oh no, probably we do not need this -1. Yeah, it should be dir subdir file1. Go. Great. And let's add it to L. L depth multiplied by 2 like this, right? Because we do not want these T's symbols too much. So let's say we have depth 3. T and T. Yeah, but this is an index, so we want depth minus 1 by 2. I'm not sure at all. Okay, let's do gsub. We want to replace this with nothing. Now probably like this. Great. Dir subdir 2 and also plus equals this and gsub again. Oh. Okay. This is our S. This is our S. Such a stupid thing to say. But it's true. We returned S. And now let's have a max. It's 0. So this is our S, and max is gonna be equal to S length if S length, well, let's do it an old-fashioned way. S length or max, believe it or not. And we want to return max in the end. 21, 20, 55, 32. Ooh. Okay, let's create an array results, and we want to add, oh, of course, after that, oof, a zombie killer whale. Did you find some interesting trick, or you just used a brute force approach? But I'm close, I am close. Yeah, Now it's just 1. The difference is 1. But maybe they just want length 0 indexed. No? Well, I just want can return max -1 and we gonna have our result, I guess. But I do not know where we lost this one. No. ATXT. Oh, it's a file. Well, I think you use a stack, because I also use a stack without calling it stack, because we always need the last element of each depth, you know? I use it too, but I do not call it stack, it's just an array and I take the last element from it. So it's the same thing. The problem is we have different extensions for files. It can be ext. So if we have a dot in a file name, or in a string, then this is a file name. Oh, only a stack. That's interesting. But let me solve it this brutal force way for now. But is it possible for a file name to contain more than one dot? I don't know. I'm probably gonna hit some test case. And it's not file, it's dot. Oh, then we do not need this check also. Ah, go. Go, go, go. I should have taken this test case. Look at this. A, B, T, so it's alright. This check doesn't make sense anymore. Okay. This one is broken, it's -1. Oh, of course it's -1. It's interesting. Where do we lose like here they say 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh yeah. And why? For me it's 21. Okay, let's find out why. Let's add everything to the array of results. And let's return this results array and we're gonna see. Aha. Of course. Well, it's not beautiful, but I want to solve it. Oh no. Oh, of course. It's not here, it's here. Ha. Oh no no. Stupid typo. Oh come on. Everything against me today. Come on. It's another way around. Great. Now we can return just max. And it's going to be 0 when we need it to be 0. I think it's gonna work. Of course not. Because we have file in a file in a file in a file. Oh, and it's not a problem, by the way. And in this case we won't just take long file, of course. And our input is 13. Why? Because of this. We do not have anything. So let's check. It's getting uglier and uglier. Oh. That's gonna save us, I think. Let's take this test case. Run for your life. Okay. Ooh. Ah. Ah. I'm so happy. Beaten. Now the question is how to solve it. Yeah, the zombie killer whale style with just one stack. Well, yes. When we iterate, if we have more t's than we used to, then we add to stack. If we have less, then we remove from stack and then add. Yes, but after that, how do we create a string from stack? Well, we can, yeah, it's not a problem. So the only difference, well, not the only difference, but it has to do with this else. Let's say we have a stack. Let's say we have a current depth. We do not need current depth, we just need stack length. And we have depth here. And if depth is bigger than stack size, then we add to stack. Maybe something like this. What if it is equal? Then we replace. How do we replace in a stack? Can we replace? Well, in my case we can, because it's not really a stack. It's just an array. I just call it a stack. So else if they are equal, then gonna be equal this. We replace it. But what if it's smaller? And we can say a lot smaller. We want to take the difference between depth and stack size, length, size, I don't know. I should probably use size because it's a shorter word. What do we want to do? We want stack pop. And after that we want stack add, something like this probably. Not sure at all. Let me comment it out for now. I just want to know what do I have in my stack. How can I do that? I can't do that until everything is done. But let's hope I am correct. So we encountered a file. In your case, you had to take everything from stack, but it use it in some kind of a reverse order. I mean, it's ugly, but in my case, I can just join everything. Join everything using slash. And then I want to add say s equals this join. Oh, I know. Let's add to this stack our file and let's join everything. And we're gonna have this s. And after that, the same thing that I done previously. Like this max is equal to 0, max is equal to s length or max. Max. And s is equal to nothing again. Well, we do not need to do that even. And we do not need this s variable anymore. Maybe, maybe not. Okay, let me check. 28 against 20. Why? Let's have an array of results and let's see what do we have. Oh, yeah, and let's return it, of course. Well, it's nice. It's 20. In this case, this is the first one, the second one. Oh. Yeah. We do not really want no. Oh, this is a problem. Or not. Ah. Well, we do that. We created our string. I'm not sure if we want to do that. I mean, we add this to stack. We do not want to add this to stack. Well, maybe we do, but it's again, it depends on depth. Because maybe we want to replace. Oh, it's hard. We need the same check here, and that's awful. That's what we need, unfortunately. Maybe then it's gonna be better. Still working. No, no difference. Ah. Wait a second. Depth -1 we want here. This is a mistake, a grave mistake. Oh no, why? It's some stupid typo or something. Somewhere, I don't know. I want to test this logic. If we have depth 0, and stack size is also 0, stack 0 equals okay. If it's 1, depth 1, and stack size, and stack size is also 1 if it has one element. And they're equal. Oh. Somehow it worked in the first case. That's very strange. So if we have depth at all, we write something. We have depth 0, we have size 0 in the beginning. And we are here. So we add, for example, dir to our stack. So it has dir. Then wait, it worked. Is it? What happened? When did it work? How did it happen? I missed it. What was the right solution? What? But I never did that. Oh, of course, I forgot. I already solved it in a dumb way. Well, that's... Thank you for reminding me, Zombie Killer Whale. I already forgot what happened 17 minutes ago. Well, I'm happy again. It's like that Memento movie. Okay, so now depth. Here, depth is 1. And size is also 1. And we are here, and stack becomes dir and this. Well, let's check example 2, by the way. I need to reconstruct my own code. Sorry. And depth. Okay, size is 2 now. Is 2, and we hit this file. Depth is also 2. Yep. And this is a file. And it is equal to stack size. Yeah, that's why it works the first way around. But what happens next? And we have this file. Probably this is a mistake. Well, we'll see. We'll see in a moment. Now we go here. Our depth is 2. Our size is 3. So, okay. And we get index 1. Index 1. So we're gonna get, still we're gonna have dir. Oh no, wait. the difference is 1. So we're gonna pop once. We're gonna pop once. We remove this bastard. Now we have these two. Minus depth. It's like well, we can do +1, of course. I don't know if this is a good idea. Of course it's a good idea. Okay, so it's +1. And now we do this 2 times. We pop twice, we remove this bastard. And we add, yeah. Oh, wait. No, it was good. It was good. We want to pop once. We're gonna leave subdir here. We're gonna add this, not this. Subdir 1. Makes all the sense in the world. Great. Well, maybe it's gonna work now. Let's check. Probably we return something stupid. Ah, you see? You see? All green. Ah, beautiful. Beautiful. It's beautiful like diamonds in the sky. Whoa. Yeah. But now I do not enjoy this repetition. Probably we want to do this like immediately. You want to do this here. If and something like this. I don't know. Let's see. Yeah, I'm gonna check it. Of course, we have some things that we do not need anymore. Let's remove res. Let's remove hash. We split array. It's good. Depth. Maybe we can combine these two, but I'm so not sure. Oh. Let's check it right away. Let's not do too many changes without a test. Green. Nice. Now we can say this. No. It also can be simplified, I think. I mean, we want to do this for sure. Let's test. Yeah, still green. So now we want to pop in this case that's it. But it's wrong. I broke it somehow. No, that's the problem. When does it happen? Yeah, that's a problem. S length max. Use test case, run. Oh, and do you remember how I said that we have to check as often as possible nice. So here we have some problem. Well, it's depth, and this one is depth plus 1. Yeah. Well, then that's it. Okay, of course we can simplify this back into a one-liner, but I'm not sure about this. Can we do something about it? So then this is it. Yeah. Okay, I'm ready to check your solution. Stack, yes, it's the same. Split. Well, of course, we do not need that array. We never use it. That's great. Then we have a depth. I agree. And here you do what? Oh, it's here you pop. Yeah. Of course you don't pop. But you pop here. That's interesting. That's interesting. But why do we need to pop? Ain't it gonna be the same without pop? I mean, this thing is going to save you for sure. Let's check. Do we need pop? Let's remove pop. Oh. You don't need to pop zombie killer whale. Even better. Now why do I do what I do and not what you do? Why do I do that? Oh, right. In my case, it should be like this, I guess. Yeah. I'm not bad. You know, we can troll them a little. We can put everything here. Had to save some lines. Yes, it's ugly, but that's my second name. So that's it. Well, I am happy that I was able to solve this problem. I'm happy that gods of random gave me 100% in the end. It's nice. Yeah, thank you. You did very good too, zombie killer whale. I mean, it's Ruby and you just solved it after Python. I don't know how you did that. That was beautiful. But that's it for today. I do not know why zombie killer whale is not asleep yet. He's probably going to regret this tomorrow. Yeah. Well, that's it, boys and girls and whales. It's time to travel, it's time to go. I'll see you tomorrow. Goodbye, thank you for being here.